Finding the inverse of element under operation. These are two questions that can trouble you under binary operation. How do I find the inverse? How do I find the element? Know that. How do I find the identity element? Know that. What do you mean by identity element? Identity element is that element that when you use the operation you are given with that with the identity element, it must give you that same number. Assuming I'm having plus as the operation. Under that plus, the identity element for plus is 0 because any number added to 0 will give me that same number. That means it's an identity what? Element. If I had that number 2, if I had any number to 0, it will give me the same number. If my operation is multiplication, if I had any number to that number, what is the number that if I multiply with the identity element will give me the same number? It's 1. So under addition, the identity element is 0. Under multiplication, the identity element is what? 1. I'm using that multiplication and addition as an example. Those are operations that we are familiar with. But they can give us other operations. You can see the operation given to us. It's asterisk here, and this is the operation. This is what you should do with this operation in this question. So finding the inverse element, you are going to rewrite it that the inverse element is identified with E. So I will say P under the operation with that E must give me P. P under this operation must give me what? P. So I will now make E subject to formula in this place. That will give me what P, what is E itself, which is the inverse, the identity element. Because we need the identity element before we can get the inverse. Because what we have to find is inverse. Inverse is P asterisk. The inverse of P must give me E. So I have not gotten E, so I have to get E first before I can put it here. So what is my E? The identity element. So I'm coming to say, okay, this is my E. E is from this equation 1. From 1, I'm going to say, okay, P asterisk E, which means P plus E minus P E is equal to what? P. I want to get E. So I'm going back to say, okay, what is that thing? Correct my terms rather. So I'm bringing it. P is going out. I have E minus P E equals to P minus P. This is automatically 0. So I'm having E minus P is equals to what? 0. E minus P E. So I'm taking P to the other side. E is equals to P E. So I'm getting what is E? No, rather, I'm not taking P to the other side. It will not make sense. I'm correct. What is common here? E is common. 1 minus what? P equals what? 0. We're getting it. The value said by this. So E is equals to 0 over 1 minus P, which is equals to what? 0. So the identity element for this thing is 0. So definitely, for me to get the inverse, I'll go back to the inverse. Inverse is to say P asterisk P inverse must give me E from equation 2. So what is E? E is 0. It must give me 0. So I'll use this operation here. I'll say, okay, P, this means P plus P inverse minus P inverse equals to 0. So this one is going to this side. That will be P inverse minus P inverse equals to minus P. What's common here? What's common here is P inverse. P inverse equals to 1 minus P equals to minus P. So therefore, P inverse is equals to minus P over 1 minus P. Which if I turn it around, that will give me P inverse is equals to minus P over 1 minus P. I'll read this minus that will be P inverse equals to P over the minus you multiply this one. Minus that will be what? P minus 1. That's our P that's our inverse element, which is C. That's it. Don't mind that it's long. It's long. If you understand the concept, you can solve it by yourself. You will not need to go through all these routes. So that is that.